Imagine being able to connect with anyone, anywhere in the world instantly, without the limitations of traditional terrestrial infrastructure. This is the promise of Starlink, SpaceX's ambitious satellite internet constellation, which is revolutionizing global internet access. Starlink's primary goal is to offer high-speed global internet coverage, particularly in remote or underserved regions where traditional infrastructure is lacking. By leveraging a constellation of low Earth orbit, or LEO, satellites, Starlink aims to bridge the digital divide, enabling better access to education, healthcare, and economic opportunities worldwide. Traditional internet systems reliant on terrestrial infrastructure such as fiber optic cables and cellular towers face major challenges in rural and isolated areas. Starlink bypasses these obstacles by providing direct satellite communication, offering a solution to regions with minimal or no access. Now, let's take a brief look at the history of internet connectivity. In the early days of home internet access, dial-up modems connected users to the internet via standard telephone lines. This required no new infrastructure other than the telephone lines already in place, but it was slow and unable to handle large amounts of data. As demand for faster internet grew, broadband technologies such as DSL and cable internet were introduced. These systems used existing telephone or cable lines, but with advanced technology that allowed for higher speeds and simultaneous voice and internet services. In the 1990s, satellites began providing internet access in remote and rural areas where traditional cables couldn't reach. Geostationary satellites, or GEOs, were launched to cover large regions, offering internet and communication services to underconnected parts of the world. GEO satellites orbit the Earth at around 35,000 kilometers. The communication was via satellite dishes on the ground, which sent and received signals to the satellites. Although this enabled internet access in remote regions, high latency and limited bandwidth became significant challenges. Low Earth orbit satellites are placed much closer to Earth, between 340 and 1,200 kilometers, offering distinct advantages over traditional GEO satellites. Their proximity enables faster internet speeds, reduced latency, and greater capacity, improving the overall internet experience. Despite the new and exciting innovation of LEO satellites, we do foresee some potential challenges. LEO satellites experience more atmospheric drag, requiring more frequent replacements than GEO satellites. Additionally, since LEO satellites orbit quickly, user terminals need to constantly track moving satellites and hand off signals between them, which requires sophisticated tracking technology. Lastly, launching large constellations of LEO satellites can be expensive, although companies like SpaceX have helped reduce cost with reusable rocket technology. LEOs present an exciting opportunity for business and industry. LEO satellites provide internet access in isolated areas, enabling remote work, telemedicine, and access to educational resources. Agriculture and resource extraction is another industry that might significantly benefit from this disruptive innovation, as industries in remote areas like mining, agriculture, and energy benefit from reliable connectivity to improve efficiency and safety. Similarly, military and emergency services will likely benefit from LEOs. In disaster zones or regions without terrestrial infrastructure, LEO satellites enable secure communication and operational coordination. LEO satellites are more environmentally friendly than their GEO counterparts and previous technologies due to their efficient design, ability to deorbit, reduced space debris risk, and minimal reliance on ground infrastructure. Additionally, their ability to support green technologies and renewable energy use further enhances their sustainability.
Starlink, developed by SpaceX, is a LEO satellite network designed to provide high-speed, low-latency internet access to underserved and remote areas globally. Since launching its first operational satellites in 2019, Starlink has been rapidly expanding its constellation to offer comprehensive global coverage. Starlink represents a disruptive innovation by bypassing traditional infrastructure like fiber optic cables and cell towers. It offers a new model of global connectivity through satellite constellations, especially in rural, remote, and disaster-prone areas. In terms of the S-curve and future growth, Starlink is in the early stages of adoption, with ongoing deployments of satellites and improving service. As adoption grows and service quality improves, Starlink could become the dominant provider of internet connectivity in underserved regions. While Starlink is not yet available worldwide, where it is available, it is currently being adopted by innovators and early adopters. These people are already aware of the need to change and are comfortable adopting new ideas.
Starlink's constellation consists of thousands of small LEO satellites that communicate with ground stations and each other to provide a seamless internet experience. Customers use a small satellite dish called Dishy McFlatface, which automatically aligns itself to the nearest satellite, ensuring continuous service. Starlink is currently the largest and most well-known player in the LEO satellite internet space, but they are not the only player. While there are several competitors like OneWeb, Amazon's Project Kuiper, Telesat, and LeoSat, Starlink stands out for a few key reasons. They have fast deployment, a global consumer focus, and operational scale. They are also backed by SpaceX. OneWeb and Amazon's Project Kuiper are significant competitors, but they're still catching up in terms of satellite deployment. As of early 2025, OneWeb has launched several satellites, but still has a long way to go to achieve global coverage. Project Kuiper has not yet launched any satellites. Telesat and LeoSat are smaller players that focus on enterprise services, and while they may have a strong business model, they are not consumer-focused or as widely deployed as Starlink. Starlink has a proven track record of delivering service to a wide customer base. Its scale, rapid growth, and financial backing from SpaceX make it a current leader in this field. When analyzing Starlink's competitors, it's important to consider the major players from the previous S-curves of internet connectivity. Companies like Bell, Rogers, T-Mobile, Verizon, and AT&T currently dominate the North American internet service landscape. The critical question facing these industry giants is whether they will adapt to transitioning to low Earth orbit LEO satellite services or risk being Netflixed.